Hello, in this video tutorial I'm going to demo writing to an avro file from a Spark job. So we'll be writing to hdfs from a Spark job running in local mode, and the file format will be avro. So avro and Parquet are hdfs friendly file formats. They are compressed, they are splittable, and it's predominantly used. So avro is a raw file format and Parquet is a columnar file format. So firstly, in a pom.xml file you need to bring in the avro jar files. So if you look at it here, we are using the avro version 176. CDH stands for the Cloudera 583 version, and this artifact will be downloaded from the Cloudera repository. So that's the path to the Cloudera repository. So that's all in the pom.xml file. And then at the end, like the way we brought in the HBase, Spark libraries, we need to bring in the avro library as well. The group ID is org.apache.avro. The artifact ID is here, and that's the version number. So avro version is what is at the top, and the provided means it's mainly used for compiling. When we build the jar file and run it in yarn, we don't really need to include this jar inside because the Cloudera environment will have the avro jar files in it. So we only require this for it to compile. So once the pom file is out of the way, you will see inside the Maven dependencies it will bring in the avro jar file. So it will be in one of these jars. Because it's a recursive dependency, the avro jar will depend on other jars and so on, so it will bring in all the relevant jars. Now let's look at a Spark code that writes to an avro file. So firstly, we are creating a Spark conf. We're calling it a simple Spark, and the set master to local, and asterisk means the local will run with multiple threads or multiple executors. Because it's a local mode, the driver and the executor will be running within the same JVM. Then we are using the Spark serializer. So if to the Spark conf, we are setting a new serializer, and it's called the cryo serializer. So if you don't set the cryo serializer, by default Spark jobs will be using the default Java serializer. The default Java serializer is highly inefficient for processing very large files. So it's inefficient in terms of CPU, it's inefficient in terms of memory, and so on. So cryo serializer is a Java based serializer which is a lot more efficient than the default Java serializer. And then I'm also registering the generic data, which is one of the avro library files. Then we are creating a Spark context. Then I'm here. So there's a concept called generic record. So generic record in avro, you can think it of as a name value pair. So you can add first name equals John. That's a name is first name is the key and John is the value, and so on. So you can have any number of key value pairs. So we are creating a list of generic record and arrays.asList. So we are creating a new list, and then I'm having two entries. One is the order ID and the other one is the order name. So 1, 2, 3 John, 4, 5, 6 Peter, and 7, 8, 9 Samuel. Avro files also need to have a schema. So the schema will be in like a JSON format. So here when you are creating an avro record, I'm getting a list of generic records back. So if I press F3 to go into this method, or alternatively I can press Ctrl and say open implementation. So this create avro method takes the order ID and the order name, and from here it gets a schema. So schema is just a name JSON format. So you can say the namespace. So all these escape characters is making it a little bit harder to read, but it's basically a JSON schema. So it says namespace is equal to example.avro is more like package. Then type, and he's saying it's a record type, and we are having a name called order. Then it has fields called order ID, which is of type integer, and we have order name, which is of type string. Then you need to do the schema parser and return you the schema object. Then generic record, you create a generic record, and as I said, the key value pair. So to the generic record you put order ID as the key and actual value of the order ID. Then put order name and actual value of the order name. So once you get these records, you need to create, so parallelize will create your resilient distributed data sets, RDDs, and coalesce one means there's only one partition. So if you have multiple partitions, it will create multiple part files. So coalesce into one. So basically the coalesce here is not required, so basically you can coalesce it just before saving it. The reason we are converting an RDD into a pair RDD here, so the next step is to create a pair RDD. The pair RDDs are used in Spark quite often. So for example, it's like a key value. So when you have a pair RDD, you can do joins like left outer join, inner join, right outer join on a certain key. You can do group by, reduce by key, and so on. But in this case, we are creating a pair RDD because there's a method called save as new Hadoop API file, and this save as new Hadoop API file just works on the pair RDDs. So we are creating a pair RDD. Basically the pair RDD is saying, normally in pair RDD you specify key value pairs. A typical example would be when you are creating a sequence file. Sequence file will have a key and a value, but for the avro you only have one value, which is a generic record. So we are creating an avro key with a generic record and the value being void, that means it's null. So when you do the map to pair, we are getting a tuple 2. So tuple 2 means there will be two values in, so we take tuple 2 from Scala because Java doesn't have tuples. So this Scala dot tuple 2, so tuple 2 means it will have two values. So in this case those two values are, one is the avro key and which of type generic record. So as I mentioned before, the generic record is like a key value pair that you can package into a generic record, and the value is void, which is null. So now we have a Java pair RDD which got tuple 2s and avro key being a generic record, this which will hold the actual value like 1 2 3 John, 4 5 6 Peter, 7 8 9 Samuel, and value is obviously null, there's no value. Then we are setting the configuration object, which is this Hadoop configuration.set the default fs. So the fs.default fs, this means we are connecting to Cloudera, so which is running on quickstart.cloudera on 8020. So this is basically the URL to the name node. So we can either do this, or in the previous tutorials we looked at, we can do add resource and pass the path to the core site.xml file. The core site.xml file will have an entry of this type, name fs.default.fs. So if you want to have a quick look at it, so it will be in the, I'm going to change directory to etc Hadoop conf. So if I do lsltr, there should be a file core site.xml. So if I do cat core tab site.xml, and if I do more, there will be a file. This is the entry fs.defaultfs, and it tells you the path where the Cloudera name node is running, so name service basically. So if you put that, then it knows how it can connect to hdfs to save the avro file. All this data will be written as avro file into hdfs. Now I'm providing an hdfs path. In this case it's user Cloudera, that's the default user path. Then another folder will be created called avro, and this data will be going into a folder called orders. So you need to create a job here. Then to the avro job, you set the output key schema. So you say this job will be using get schema. So whatever the schema we are using, you'll be using this particular schema. So avro and parquet files need to have a schema. And then on the pair RDD, which we constructed earlier on with the key and value being null and the key with generic records, we do save as new Hadoop file. So the save as new Hadoop file is a very generic. You can use it to save text file, you can use it to save sequence files, you can use it to save avro file, you can use it to save parquet files. So the things that are being different is here's the hdfs path where you're going to write it to, and avro key.class. So because it's an avro, in this case avro key.class. If you're writing as a text, it will be text.class. If you're writing as a byte writable, it will be byte writable.class, and so on. So you have to use the right class here, and the value being null. So this is null writable.class, because as I said before, there's a key value and we're not using the value here, only the key, because unlike the sequence files, the avro files don't have key value pair. So you only need to either provide a key or a value. You can actually provide both, but there will be different values. We will look at this in another tutorial. Then we have to say avro key output format. So this is the output format class. So this is the one knows that, okay, I have to write this as an avro file. So that's why it's called avro key output format. Then we are doing a job.get configuration. Then we are closing the Java Spark context. So the job.get configuration will get you the configuration from the job we set, and in the job we are also setting the output key schema to the schema that we have prepared here. So before I start running this, I'm going to go and delete it because I previously ran this. So normally what you do is, if you're running a job, you will be running under a particular year, month, date, a date value, or you'll be writing for a particular day or particular hour or so on. Or alternatively, you'll be writing into a temporary area, and then you'll be moving stuff from the temporary area into your actual orders area. But in this case, I'll be writing directly to the orders, and then I'm going to go into Hue, and Hue is a Hadoop user experience. I'm going to go to the file browser. I'm going to look at that folder avro, and I'm going to delete the orders which I ran before. So highlight this and click on move to trash and say yes. And then I'm going to go into Eclipse, right click on write as avro to hdfs, right click on it and run as Java application. So there's no orders file here. We only have the order.avsc, which stands for avro schema. I'll talk about this avro schema later on. When you create a Hive table over avro, you need to have a schema in hdfs, so you can create a table. So when this job runs, so start of the avro job, this is a DAG scheduler, which all is basically the Spark initialization is happening. So once this job completes, now the job has completed, you can see here now. Now if I go into Hue and I just refresh this, see here it has created the orders. So basically it creates a folder called orders, because we are writing here to the path of orders, and this is a very trivial small files. In a real job you'll be running a 2 GB file or a 5 GB file or a 100 GB file. It's going to create a lot more records, and you might even run a 1 terabyte file, and it is also going to create multiple partitions. And then what's going to happen is when you write to it, when you click on the orders, you're going to end up with multiple part files. So each partition will be written to its own part file. So this is a very simple file with 3 entries. If I look at this, so there will be success is saying the job has succeeded, and part R file is saying this is one of the files that got the data. So the data is in avro format. So don't be misguided by this looking like a JSON thing. It is basically the hue is outputting a rendered compressed file. So it has already run something to read a compressed file in binary format. The native format in which it will be stored is, if you click on the view as binary, this is how the actual avro file is, which is a binary file. But if I do view as text file, or if I go to avro tools from the command line, and if I type to JSON or whatever, it will give me the text representation or a JSON representation of the actual avro file. So here you can see order ID 123, order name John, order ID 458 Peter, order ID 789 Samuel, and so on. So now we have written to avro. The next step is see how to read from an avro file. So if we go in here and I go to read from avro file from hdfs, this is the code. It's very similar. Create a spark conf, and I'm calling a read from an avro in hdfs, setting the master to local mode. We spoke about the initial serializer, so we're using the avro serializer here. Then this is the path actually the file is sitting. So in the quickstart.cloudera, which is the host name, 8020 is the port on which the name node is running, and user cloudera avro orders is where we wrote this file to user cloudera avro orders. So that's the path where the file is residing. Then we are doing the reverse. So before, what we did was we created a pair RDD from the RDD, and from the pair RDD we say save new Hadoop API file or whatever, and then it saves. And this time from the Java Spark context we are using a method called new Hadoop file. So before we were writing, we use a method called save as new API Hadoop file. It's called new API Hadoop file is because there are another method called save Hadoop file, but this is the new API, so that's why it's called save new API Hadoop file as opposed to save Hadoop file. Similarly, this is also called new API Hadoop file. And then, as I said before, this is a very generic format, so depending on what format class, what key class, everything you're providing, it will know what type of file is going to read. So in this case, because we're going to read an avro file, it's called avro key input format.class, and then it's an avro key.class, which is the key, and the value is null, because as I said before, key value, you're only providing the key, not the value. So if you hover over the new Hadoop file API, you will see it takes a string path. So this is the path it's going to read from. That's the path. What kind of class you're going to use? So we are saying it's an avro input format class. So here we are saying avro key output format class, and here because that's we are writing, and here we are saying avro key input format class because we are reading, and here we are using avro key. Same here, we are using avro key as the key, and we are using a null writable, which is a void, as a value to read, and here also we are using null writable void as a value. So when we read here, before we went from pair RDD to save it to the thing, now here we are reading it, what we get is a Java pair RDD. So Java pair RDD will have the key, and also it will have a value. So in this case, the key is a generic record. So generic record, as I said, is an avro. You can store it as name value pairs, and key is the void, value is void, so there's no value here, so just a key. And then from the pair RDD, getting all the keys, because we are only getting the key here, that gives you a generic record, and for each, and just I'm printing it out. So I'm going to run this now to see if we can read the data from hdfs. So I'm going to run as, sorry, this is write to. So read an avro file from hdfs via Spark. So just run as Java application. So if it works, you won't see any errors here, and it will be printing out the values that it read. So in this case, we know the orders. There are 3 values here. You can see it under 1, 2, 3 John, 4, 5, 6 Peter, 7, 8, 9 Samuel. So it has finished running. So I'm going to double click on it to make it begin. See any errors? No errors. Here we go. These are the values. Order ID 1, 2, 3, order name John, order ID 4, 5, 6, order name Peter, order ID 7, 8, 9, order name Samuel. So in the next video tutorial, I will look at something called avro tools that you can use in a command line. So if already you don't have the avro tools, you can download the jar file and you can install it, avro tools. So basically it got a number of methods. You can extract the schema, you can convert it to a JSON and view an avro file, because avro is a binary file. So if you want to view it, you can do it from a command line, and you can convert it to a columnar format, which is a true Trevini, which is a columnar format. So that's all for this tutorial. So in the next tutorial we'll cover avro tools, and also instead of using a generic record as we have seen here, we can create specific Java objects from something called avro ideal interface description language. So an interface description language is you define the schema in a kind of a description format, and then you can automatically generate Java objects, and you can assign your values to Java objects and pass and create a Java pair RDD from those Java objects, and then you can write it as an avro file, which is more like, for Java developers more familiar with. So for example, when you're working with an XML file, you marshal unmarshal XML files to Java objects, and then you work with Java objects, and you can unmarshal it, and then you can marshal it back. So very similar concept. You can write an interface definition language in avro, and then you can convert that to Java objects, and you can add your values, set your values in Java objects, and then you can write it back as an avro file. We will look at those two in the next tutorial.